Okay, so let's try 52 and 5.2. And we'll try this in the coarsest possible way first. So there's a dead guy in a snowbank, I think is the bottom line of this. Yeah. So this happens occasionally in Europe, that glaciers will thaw and there will be chunks of previous societies in them. In this one, it happened to be actually a whole guy who got lost in a snowstorm or whatever.
It's like Mount Everest, there's hundreds of just dead people there.
Yeah, that also happens. There are lots of dead bodies on Everest. Most of them are not even in glaciers. They're just laying out and about.
Yeah.
Anyway, point is, fell in a snowbank a while ago, and now what we know is that 46% of the C14 in his body has decayed. Yeah. So then we also know that the half-life of carbon-14 is 5,728 years. So the question is, how long has he been in the snowbank?
Almost that.
Good. And the answer, like the obvious answer is pretty much about 5,700 years, right? Because like about half the C14 is gone, and it takes about 5,700 years for half the carbon-14 to be gone. If I want a better answer, how do I get a better answer?
0.46 times the year.
Okay, 0.46% has decayed, right? So that means that there's how much left?
86%.
I
I was thinking 16. I'm sorry. I meant 54.
0.54 left.
Okay, so there's 54% left, right? And how much did he start with?
100.
100%.
Well, how do we do that?
That's a really good question. How do we know how much carbon-14 he started with? Is a super good question. Oh, wait.
He just keeps going.
It's a long explanation, and it's super cool.
Let's do it.
I'm not doing that right now.
Wow.
So let's finish this, and then I'll talk about carbon calibrations.
Okay.
So is 100 times e to the what? R times t, right? Do I know the... Uh-oh. This may not have been the best thing for me to set up, right? Because I don't know the time or the growth rate. You guys see that? Okay, so could I go find the growth rate?
The decay rate.
Yeah, I want to find the decay rate, right? You guys see that? Because I know I'm not going to know the time, right? That's going to be the thing I have to find. But I need to know this R to start. So how am I going to find the R?
0.5 of original equals.
Yeah, so I need to set up another equation. So I know 50%, right, is 100 e to the R times 5,728, right? So 0.5 is e to the 5728 times R. And then what? Log it and then divide. So you should end up with log of 0.5 divided by 5728 is your growth rate. And then what do you do with that? Yeah, we may as well approximate because we're doing chemistry, right? So R is approximately, somebody give me a number for that? Ready, set, faster? Yeah, it's pretty small. So I'm going to go with negative, right? 0.00725. You're full of it.
I feel like that's 1, 2, 1.
1, 2, 1.
Times 10 to the negative. Yeah.
Third?
Fourth. Yeah.
Fourth. Negative fourth? Did I miss a 0?
Yeah, 1, 0.
Okay, so I got my growth rate is about negative 0.000121. And what do I do with that information?
Plug it in.
Take that and cram it in here. My first equation. And then what? Solve for t. Can anybody tell me what they got for this after they solve?
Point.
Okay. Stop be dumber, she is. What do we think it probably ought to start with? 5.
Seven.
And then the next number is probably
6.
small,
0.
or than 7 at least, right?
5, 5.
So I said 6.
Someone just, one, is it?
5, 6.
Is no one doing this?
5,092.
Nine.
My calculator.
Oh, sorry.
5,092 years.
Yeah.
Okay.
Years.
He's been dead.
Oh.
That's a good question and a weird one. Because there's no year 0. Things are a little strange with that. So what year is it now, Gibbs? Okay, so it's 2017 now, right?
2017 years.
So this is more than that, right? So yes, this is give or take 3000 BC.
3,075 BC.
3076 BC. Because this dorkness about there's no year 0.
What's the in between? The BC and AD?
There's no year 0 in the common calendar.
Yeah.
So it goes from 1 to 1 BC,
There's like
180, 1 BC, so there's one spot that's, yeah.
There was like 14 days in between before they switched from BC to AD. There was.
Okay, calendars are horrible. Bottom line. Check, done, cool, good.